Hi, I'm Dr. Pranjali Sharma, and in this video lecture I'm going to show you an example of Taylor series which is in first form, which is a part of differential calculus. We all know that Taylor series in first form is f of x plus h is equal to fx plus hf dash x plus h square by factorial to f double dash x plus h cube by factorial 3f triple dash of x and so on up to infinity. I have already explained you Taylor's first form in previous lecture. So here I am going to show you an example where we have to prove that tan inverse x plus h is equal to tan inverse x plus h sin z into sin z upon 1 minus h sin z square into sin 2z by 2 plus h sin z whole cube into sin 3z by 3 and so on up to infinity, where z is cot inverse x. So let's start. Since z is cot inverse x, so x can be written as cot z. Differentiate both sides with respect to z. Dx by dz will be minus cosec square z. Therefore, dz by dx can be written as minus sine square z. Now take it as equation number 1. Since Taylor series of first form is f of x plus h is equal to fx plus hf dash x plus h square by factorial 2 f double dash x plus h cube by factorial 3 f triple dash x and so on up to infinity. Now take it as equation number 2. Since f of x plus h has been given to tan inverse x plus h, put h is equal to 0 in the above equation. F of x will be tan inverse of x. Now differentiate with respect to x. F dash of x will be 1 upon 1 plus x square. From equation 1, x can be written as cot z. So put value of x over here. F dash of x will be 1 upon 1 plus cos square z, which is equal to 1 upon cosec square z, which is equal to sin square z. So f dash x is equal to sin square z. Now differentiate again with respect to x. So f double dash of x will be 2 sin z cos z dz by dx. From equation 2, dz by dx is equal to minus sine square z. So put the value over here and f double dash of x will be sine 2z. Since we all know that 2 sin z cos z is equal to sine 2z and it is equal to minus sine square z. Alright. Differentiate one more time. Differentiate with respect to x again. So on LHS it will be f triple dash x and on RHS it will be first function differentiation of second plus second function differentiation of first. So it will be sine 2z 2 sin z cos z. Since we are differentiating with respect to x, therefore it will be dz by dx plus sin square z 2 cos 2z dz by dx. So as we can see, 2 sin z and dz by dx is common. So take it out. And in bracket we have sin 2z cos z plus cos 2z sin z, which is sin a cos b plus cos a sin b, which is sin a plus b, and the value of dz by dx from equation 1, dz by dx is equal to minus sin square z. So it will be minus 2 sin z into minus sin square z into sin a plus b. That means sin 2z plus z. That gives us 2 sin cube z into sin 3z. So we have value f triple dash x, f double dash x. Here we have f dash x. Here we have fx. Put all these values in equation number 2. So put values in equation number 2 to get the result. So let's see, f of x plus h was tan inverse x plus h is equal to fx was tan inverse x plus h into f dash x. F dash x is, as we can see, it is sin square z plus h square by factorial to f double dash x. We have calculated f double dash x and it is equal to here. So it is, as we can see, minus sin 2z sin square z. Alright, and h cube upon factorial 3f triple dash x. So it is 2 sin cube z sin 3z and so on up to infinity. So we can rearrange it as tan inverse x plus, we are only rearranging, h sin z into sin z minus h sin z whole square into sin 2z upon value of factorial 2 is 2 plus h sin z whole cube 2 upon factorial 3 is 3, so it will be sin cube z upon 3 and so on up to infinity. Hence the result has been proved using Taylor's first form. Next I will teach you another example of Taylor's first form. So let's see another example. So we are having another example of Taylor series in first form, and it says that find value of cos 32 degree using Taylor's series. So here I am using Taylor's first form to find the value of cos 32, and as I have already explained you what is Taylor's first form, that f of x plus h is equal to fx plus h f dash of x plus h square by factorial 2 f double dash x and h cube by factorial 3 f triple dash x, and series will go on up to infinity. So take the formula of Taylor's first form as equation 1. Now since we have to expand cos, so take f of x plus h is equal to cos of x plus h. So put h is equal to 0 on both sides. It gives us the value of f of x which is needed to form the series. So put h is equal to 0, fx is equal to cos of x. Now differentiate both sides with respect to x. We will have f dash of x as minus sin x. Differentiate above line with respect to x again. We have f double dash x as minus cos x. Differentiate the line once again with respect to x. We get f triple dash x as sin x. So the cycle has been completed almost. If we differentiate one more time, it gives us f fourth x as cos x. Now put all the values in the formula of Taylor's first form, which is in equation 1. So our f of x plus h was cos x plus h. So put fx plus h as cos x plus h. Fx cos x plus h f dash of x. So it will be h into minus sin x plus h square by factorial 2 f double dash x, which is minus cos x, plus h cube by factorial 3, and differentiation of minus cos x, which is f triple dash, and it is equal to sin x, plus h to the power 4 by factorial 4, and f fourth derivative of x, which is again cos x, and so on up to infinity. Now take it as equation number 2. Since we have to calculate value of cos 32 degree, so we put x as 30 degree and h as 2 degree in equation number 2. So 30 degree plus 2 degree, on left hand side we have cos 32 degree. Let's see on right hand side. So cos x, cos 30 degree minus 2 degree into sin 30 degree minus 2 degree square by factorial 2 into cos 30 degree plus 2 degree cube by factorial 3 sin 30 degree plus 2 degree to the power 4 by factorial 4 cos 30 degree, and so on up to infinity. Now put values of sine 30 degree and cos 30 degree, and change the 2 degree in radian, since we know that pi radian is equal to 180 degree. Therefore 1 degree can be written as pi upon 180 degree, which is approximate 0.0174. So we calculate the series cos 30 degree, that is root 3 by 2 minus 2 into the value of 1 degree in radian, that is 0.0174, into sine 30 degree, which is 1 by 2, minus 2 into 0.0174 whole square by factorial 2 into cos 30, that is root 3 by 2, and so on up to infinity. So when we calculate all these value, it gives us approximate value, since series is having infinite terms and infinite terms can't be calculated. So we have approximate of all these calculations as 0.8482, which is approximate value of cos 32 degree. Hence in this video lecture